Namaskar, dear students, welcome. In the last class, we discussed about the exact differential equation, the necessary and sufficient conditions for a differential equation of the form m dx plus n dy equal to 0. M and n are functions of x and y. To be exact, is del m by del y equal to del n by del x. And we discussed about the working rule to find the solution of an exact differential equation. What is exact differential equation? A differential equation of the form m dx plus n dy equal to 0 is exact if there exists a function u of x and y such that du is equal to m dx plus n dy. This means that the differential equation is said to be exact if the left hand side means m dx plus n dy is a perfect differential. We should find, if we can find a function u such that du is equal to m dx plus n dy, then this differential equation is said to be exact. Therefore, an exact differential equation can be solved in two ways. In the last class, we solved 4 problems. Today, we shall solve some more problems on exact differential equation. Suppose this is example number 5. Therefore, since we solved 4 questions in the last class, solve 1 plus e to the power y cos x dx plus x e to the power y sin x dx dy equal to 0. Suppose we have to solve this differential equation. We shall solve every all exact differential equations in 2 ways. Here, if you compare this differential equation with m dx plus m dy equal to 0, then here m equal to you will get 1 plus e to the power y cos x, m equal to e to the power y sin x, del m by del y. What is del m by del y? Del m by del y is del y of 1 plus e to the power y cos x. This is equal to, if you are differentiating a function of x and y partially with respect to y, you should treat the other variable as constant. Treat cos x as constant. If cos x is constant, differentiate this, it will be 0 plus e to the power y. Obviously, it will be e to the power y cos x. Now, del n by del x. What is del n by del x? With respect to x, here treat y as constant. It will be e to the power y cos x. E to the power y cos x. Thus, del m by del y equal to del n by del x. Del m by del y equal to del n by del x. This differential, suppose this is marked this is as 1, differential equation is 1. Since differential equation is exact, what is the solution of this? Solution of the differential equation 1 is, therefore it is exact, therefore 1 is exact. You may say, therefore 1 is exact. Therefore 1 is exact. 1 is exact. Exact differential equation. Exact means it is an exact differential equation. Solution of 1 is integral m dx. Integral m dx. Treating y as constant. Treating y as constant. Treating y as constant. plus integral m dy. This is equal to integral m dy. Here taking only those terms of m, taking only those terms of m, only those terms of m which are free from x, which do not contain x, which do not contain x. This is equal to constant, contain x, which do not contain x, contain x. This is equal to constant. Integral m dx, treating y as constant, plus take only those terms. Here m is this 1 plus e to the power y cos x. Take y as constant and take only those terms which do not contain x. Here only one term is there, e to the power y sin x. This term contains x. Therefore, integral m dy equal to 0. Integral m dy equal to 0. This means integral 1 plus e to the power y cos x dx plus 0 equal to constant. 0 equal to constant. Since there is no term in m, since there is no term in m which do not contain, which are free from x. There is no term which is free from x. You may write which is free from x, or which do not contain x. Which is free from x. Free from x. No term is there. This is equal to constant. Now take y as constant. This means if you take y as constant, this integral cos x dx, this is equal to the constant. This means 1 plus e to the power y, integration of this is sin x equal to c. Sin x equal to c. This is the answer. The answer of this 1 plus e to the power y, x equal to 0. 1 plus e to the power sin x is equal to 0. Now, alternatively, it can be also solved. Since the equation is exact, therefore you can solve it in this way also. Alternatively, suppose alternatively, 1 plus e to the power y cos x dx plus e to the power y sin x dy, this is equal to 0. Or this can be written as cos x dx plus e to the power y cos x dx plus e to the power y sin x dy. You may write like this. Now, this term cos x dx, this term can be written out as d of sin x. This is d of sin x. D of sin x means cos x dx plus e to the power y. You may write it as d of sin x means cos x dx plus sin x d of e to the power y. You may write like this. This is equal to this. You may write like this. Now, these two terms. First term into differentiation of the second function plus second function into differentiation of the first function. This is equal to differentiation of the product of the functions. This means d of sin x plus d of e to the power y sin x. This is equal to 0. Or you may write d of sin x plus e to the power y sin x. This is equal to 0. Or d of 1 plus e to the power y into sin x. sin x. This is equal to 0. Integrating we get 1 plus e to the power y sin x. This is equal to constant. The same, you have got the same answer. In this way also we can solve the differential equations. Let us take another example. Let us take another example. Solve. 1 plus 4xy plus twice y square dx plus twice y square dx plus 1 plus 4xy plus twice x square dy equal to 0. dy equal to 0. Here m equal to, you see, here m is equal to this, n is equal to this. Here m equal to this. Here m equal to 1 plus 4xy plus twice y square del m by del y. This is equal to del y of 1 plus 4xy plus twice y square. This is equal to 4x plus 4y. Del m by del y is equal to this. Del n by del x. This is equal to del x of 1 plus 4xy plus twice x square. With respect to x, differentiation of 1 is 0. This is 4y. This is 4x. Thus, del m by del y equal to del n by del x. Therefore, suppose this is number 1. Therefore, 1 is exact. Therefore, the differential equation 1 is exact. Therefore, the differential equation 1 is exact. The solution of the differential equation. Therefore, solution is integral m dx, treating y as constant, plus integral m dy, taking only those terms in m which do not contain x, taking only those terms in m which do not contain x. This is equal to constant. This means, what is m? Integral 1 plus 4xy plus twice y square dx plus, what is n? You see, what is n? 1 plus 4xy plus twice x square. We should take those terms in n which do not contain x. You see, इसमें तो x है, इसमें भी x है, which do not contain x. Only one term is there. This is 1. Integral 1 dy. This is equal to constant. This means it is x plus 4x plus y is constant. 4y, integration of x is x square divided by 2 plus twice y square. This is constant. Difference integration of 1. This is x plus it is y equal to constant. Suppose c is constant. This means x plus twice x square y plus twice x y square plus y equal to constant. This is that. Plus y equal to constant. Answer is this. X plus twice x square y plus twice x y square plus y, this is equal to constant. X plus twice x square y plus twice x y square plus y equal to constant. Therefore, we have solved this. This is the solution. Let us try to solve this problem in the alternative way. Alternatively, 1 plus the differential equation is 4xy plus twice y square dx plus 1 plus 4xy plus twice x square dy equal to 0. This means dx plus 1 dx 1 dy, you write dx plus dy group করবে plus take this is as a group 4xy dx plus twice x square dy, this one and this one, and you have to take this and this, plus twice y square dx plus 4xy dy equal to 0. This is another group. This means d of x plus y plus y d of x square, you may write like this. One minute. D of y d of twice x square, write it, twice x square. Y d of twice x square is 4x dx. Y 4x dx means 4xy dx plus twice x square dy plus twice y square dx plus x d of twice y square. This is equal to 0. You may write like this. Next, d of x plus y plus, what is this? First function into differentiation of the second function plus second function into differentiation of the first function. You may write it as twice x square y. Here also twice x, twice d of twice y square x equal to 0, or you may write d of x plus y plus twice x square y plus twice x y square equal to 0. Integrating we get x plus y plus twice x square y plus twice xy square equal to c. This is the answer. You have got the same answer. X plus y plus twice x square y plus twice xy square equal to 0. Therefore, we have solved two problems today. Let us take another problem. Today's 5, 6 and this will be 7. Today's problem number 3. Solve y square e to the power xy square plus y square e to the power xy square. 4x cube dx plus twice xy e to the power xy square minus thrice y square dy. Suppose this is, we are to solve this. Here m equal to y square e to the power xy square plus 4x cube, m equal to twice xy e to the power xy square minus thrice y square. Del m by del a del y equal to del y of y square e to the power xy square plus 4x cube. This is equal to, this is a product function, first function into differentiation of the second function. Differentiate x y square with respect to y. It will be twice xy plus twice y e to the power xy square plus 0. The differentiation of 4x cube is equal to 0. This is equal to with respect to y, twice y e to the power xy square twice xy square. Now del n by del x will be equal to del x of twice xy e to the power xy square minus thrice y square. This is equal to twice y. This is constant. First function x, the differentiation of the second function xy square. Again, differentiation of this is xy square plus e to the power xy square into differentiation of x with respect to x is equal to this. Twice y e to the power xy square in the bracket you will get xy square plus 1. In the bracket you will get xy square plus 1. xy. Therefore del m by del y equal to del n by del x. Del n by del y equal to del n by del x. Therefore, suppose this is 1. 1 is exact. Therefore 1 is exact. Therefore 1 is exact. Therefore del m by del y equal to del n by del x. Therefore 1 is exact. Therefore 1 is exact. It is an exact differential equation. Solution of 1 is solution of the differential equation 1 is integral m dx, treating y square x y square plus 4x cube dx, treating y as constant, treating y as constant. Integral m dy plus integral m twice xy. N is what is n? N is equal to twice xy e to the power xy square minus thrice y square. Taking only those terms which do not contain x. This term contains x. thrice y square. This term is not containing y. Therefore, you may write like this. dy. This is equal to constant. This is equal to constant. This means treating y as constant. Here y square is constant. Y square constant. Integration of e to the power x y square constant. What is the integration of e to the power mx? Integration e to the power mx. The integration of e to the power mx is e to the power mx divided by m. Here e to the power x y square. The integration is e to the power x y square divided by y square. Divided by y square. You will get this. Plus the integration of 4x cube, x to the power 4 by 4. Differentiation of x to the power 4 is 4x cube. Therefore, it is x to the power 4. Minus, it is y cube. This is equal to constant. This is equal to c, constant. C, where c is equal to constant. You may write where c is equal to constant. Where c is equal to constant. C is constant. Arbitrary constant. This means e to the power x y square plus x to the power 4 minus y cube equal to constant. This is equal to constant. Suppose this is the answer of this. E to the power xy square plus x to the power 4 minus y cube. This is equal to constant. Now we have to solve this equation in an alternative method. Since this equation is exact, therefore the left hand side should be equal to d of some function. The function should be this. D of this some function equal to 0. This is equal to 0. Now, alternatively, the differential equation is y square e to the power x y square plus 4x cube dx plus twice xy e to the power xy square minus thrice y square dy. This is equal to 0. This is equal to 0. Or you may write y square e to the power x y square dx plus 4x cube dx plus twice xy e to the power x y square dy minus thrice y square dy equal to 0. This is equal to 0. Y square, this is equal to 0. Now see these two terms. No problem. For these two terms, no problem. Now you may write 4x cube dx minus thrice y square dy plus y square e to the power x y square dx plus twice xy e to the power x y square dy equal to 0. For this term, you may write d of x to the power 4 minus d of y cube plus, for these two terms, e to the power x y square, this is common, y square dx plus twice xy dy, this is equal to 0. Twice xy dy equal to 0. Xy equal to 0. Now, let me write in this place. This means d of x to the power 4 minus y cube. X to the power 4 minus y cube. x to the power 4 minus y cube plus e to the power x y square. For this y square dx plus x, can I write like this? Equal to 0. What is d of y square? It is d of y square. dy square. dy square. dy square. What is dy square? Twice y dy. Already x is there. Twice xy dy. Twice xy dy. This means d of x to the power 4 minus y cube plus e to the power xy square d of xy square equal to 0. This is equal to 0. This is equal to 0. This means d of x to the power 4 minus y cube plus e to the power x. d of e to the power x is e to the power x dx. It is of the form e to the power x dx. d of e to the power xy square. If you differentiate this e to the power xy square, d of x square equal to 0. This is equal to 0. Or this means d of x to the power 4 minus y cube plus e to the power xy square, this equal to 0. It is of the form d of u equal to 0. They are integrating, we get. Integrating, we get. Integrating, we get. X to the power 4 minus y cube plus e to the power x y square. This is equal to constant. This is equal to constant. This is the answer. We have got the same result. We have got the same result. Let us take another problem. Now, question number 8. Today's question number 4. Today's question number 4. Suppose solve sin x cos y plus e to the power y6. E to the power y6 dx. Sin x cos y e to the power y6 dx. Plus cos x sin y. Sin y. Suppose this is tan y. dy. This is equal to 0. This is tan y equal to 0. Here m is equal to this. M is this and n is this. Here m, suppose this is number 1. Number 1. Here m equal to means a function of x and y. So m is equal to this. Cos y plus e to the power y6 plus e to the power y6 del m by del y equal to del y of sin x cos y plus e to the power y6. This is equal to, with respect to y, treat x as constant. Simply it is sin x. Sin x is constant. Sin x constant. What is the differentiation of cos y? Minus sin y. This is equal to minus sin x cos sin y. Sin x sin y. N equal to del n by del. N equal to cos x sin y plus tan y. Del n by del x equal to del x of cos x sin y. Here e to the power y6 is treat e to the power y6 as constant. Therefore, del y of e to the power y6 is equal to 0. Plus tan y. Plus tan y. You are differentiating partially with respect to x. y is constant. Therefore, it is sin y. The differentiation of cos x is minus sin x plus 0. This is equal to minus sin x sin y. Minus sin x sin y. This is minus sin x sin y. It is minus sin x sin y. Sin x sin y. Thus, del m by del y equal to del n by del x. Therefore, del m by del y equal to del n by del x. Therefore, del m by del y equal to del n by del x. Therefore, the differential equation 1 is exact. The differential equation 1 is exact. Exact differential equation. Solution is integral m dx, treating y as constant. Treating y as constant. Y as constant plus integral n dy, taking only those terms which do not contain x. Taking only those terms in m which do not contain x. Only those terms which do not contain x equal to constant. This is equal to constant. This is equal to constant. The solution is this. This means what is m? Sin x cos y plus e to the power twice x dx. Treat y as constant plus what is n? Cos x sin y plus tan y. Cos x sin y. X is here. It contains x. Therefore, we should reject this term. Plus tan y. Integral tan y dy equal to constant. This is equal to constant. This means here cos y is constant. Cos y integral sin x dx plus integration e to the power twice x is e to the power twice x divided by 2 plus log of sec y. Sec y, this is equal to the constant. Log of sec y, this is equal to constant. This means cos y integration of sin x is minus cos x plus 1 by 2 e to the power twice x plus log of sec y. Log of sec y equal to c. Therefore, answer is this means minus cos x cos y plus 1 by 2 e to the power twice x plus log of sec y equal to c. Answer is this. This is the answer. Minus cos x cos y plus half of e to the power twice x plus log of sec y equal to constant. This is equal to constant. This is the answer. Now let me solve this problem in the alternative way. Alternatively, the given differential equation is sin x cos y plus e to the power twice x dx plus cos x sin y plus tan y dy equal to 0. This means e to the power twice x dx, for this term there will be no problem. E to the power twice x dx and tan y dy plus tan y dy, no problem. For these two terms group, take it as group. Cos x, sin x cos y dx plus cos x sin y dy, this is equal to, this means you may write it as e to the power twice x divided by 2 plus d of log sec y plus cos y d of sin x dx minus cos x dx. You may write like that. For d of minus cos x means it is sin x dx, cos y dx. d of minus cos x sin x dx is equal to d of minus cos x. Plus cos x plus cos x sin y dy, d of minus cos y equal to 0. Minus cos y equal to 0. Or for first two terms, you may write e to the power twice x by 2 plus log of sec y plus, here you see, minus cos x, it is plus cos x, plus cos y, it is minus cos y. You may write it as minus of minus cos y d of minus cos x. You may write like this, minus cos y it is remains unchanged. For cos y, minus cos y with a minus sign. Here also minus cos x d of minus cos y minus cos x minus cos y d of minus cos y. Can I write like this? This is equal to 0. Minus, no problem. Let me write in this space. Alternatively we are writing this one. This means d of e to the power twice x by 2 plus log of sec y minus cos y minus d of minus cos x plus minus cos x d of minus cos y, this is equal to 0. Or d of e to the power twice x by 2 plus log of sec y minus, it is first function differentiation of the second function, the product function like this, minus cos x minus cos y equal to 0. We may write like this. This means d of e to the power twice x divided by 2 plus log of sec y minus d of minus, this is plus cos x cos y equal to 0. You may write like this, cos x cos y write like this. Or you may write d of e to the power twice x by 2 plus log of sec y plus log of sec y minus cos x cos y minus cos x cos y equal to 0. You may write like this. Integrating we get integrating we get integrating we get e to the power twice x by 2 plus log of sec y minus cos x cos y equal to constant equal to constant equal to constant. You have got the same answer. You see the page number. We have got the same answer. We have got the same answer. Therefore, we have solved this problem also in two different ways. In two different ways, we have solved this one. Now, let us take another problem. Problem number 9. Solve. Solve. Y 1 plus 1 by x del del y plus dx. Dx is this plus x plus log x minus sin y minus x sin y dy. Suppose solve this one. Solve this one. Here m equal to y 1 plus 1 by x plus cos y and n equal to x plus log x minus x sin y minus x sin y del m by del y equal to del y of y 1 plus 1 by x plus cos y with respect to y. Treat x as constant. 1 plus 1 by x. This is 1. And it will be minus, sin y. Minus sin y. 1 plus 1 by x minus sin y. Del n by del x. Del n by del x equal to del x of x plus log x minus x sin y. This is equal to 1 plus 1 by x with respect to x. It is minus sin y. Therefore, del m by del y equal to del n by del x. Therefore, del m by del y equal to del n by del x. Del n by del x. Therefore, that suppose this is number 1. Therefore, the differential equation 1 is exact. Therefore, the differential equation 1 is exact. Therefore, the differential equation 1 is exact. Differential equation 1 is exact. 1 is exact. 1 is exact. Solution of 1 is integral m 1 plus 1 by x plus cos y dx. Treating y as constant. Here, treating y as constant. Y as constant. Plus integral m and dy, taking only those terms which do not contain x. What is n? X plus log x minus x sin y. No term is there, no term which do not contain here 0, 0 equal to constant. Since n equal to x plus log x minus x sin y, there is no term which is free from x. Since there is no term in n, there is no term in n free from x, which are free from x, which do not contain x. No term is there, therefore it is 0. Now this means integrate this, taking y as constant. Y take outside. Integration of 1 is x plus it is log x. It is log x.